Hello friends, welcome to my channel. In this video I will cover engineering mathematics Laplace transform part. I will cover. This is part 2. Question is find Laplace of t square e to the power 3t. Here already in first video I already discussed fast shifting theorem. This is f of t and this is e to the power at. A is 3. So from fast shifting theorem we know Laplace of e to the power at f of t. First if we will find Laplace of f of t, capital F s, we will get, here we will shift f a minus a. If it is e to the power plus a, then you will get f s minus a, and if it is e to the power minus a t f of t, you will get capital F s plus a. So here in this question f of t is t square. So first we will calculate in step 1 Laplace of f of t, Laplace of t square. T square is, our formula is n is 2 here, n factorial divided by s to the power n plus 1. So 2 factorial is 2, s cube we will get 2 by s cube. Then we will multiply e to the power at in second step. So a is here 3, you will get f of s minus a. So 2 divided by s minus a is 3, its whole cube. This is your answer. Just apply fast shifting theorem. In next question, find Laplace of e to the power minus 2t sin 4t. So first, this is e to the power at and this is f of t. So first we will calculate Laplace of sin 4t. Here omega is 4. We know Laplace of sin omega t is omega divided by a square plus omega square. So directly we can write here omega is 4, a square plus 4 square. Then in second step, Laplace of e to the power minus 2t sin 4t. Here a is minus 2. So s term we will get plus 4 by s plus 2 square plus 4 square. This is your answer. Or if you solve further, you will get 4 divided by s square plus 4s plus 20. This is your answer. Then next question, find Laplace of e to the power 4t cos h 5t. We know cos h omega t. Here we will get plus term s square divided by, s divided by s square plus omega square. Here we will get minus term. So here omega is 5. First we will do Laplace of cos h 5t s divided by s square minus 5 square is, or simply we can write 5 square. In step 2, apply second shifting theorem e to the power at. Here e to the power 4t, so a is 4. And it's at, a is plus, so in s term we will minus it. Laplace of e to the power 4t cos h 5t, you will get s minus 4 divided by s minus 4 whole square minus 25. So if you solve further, you will get s minus 4 divided by s square minus 8s minus 9. This is your answer. You just have to remember the formulas. In part 1 of this video series, I already discussed these formulas. Then second shifting properties. In second shifting property, if Laplace of f of t is capital F S and g of t equal to f of t minus a when t is greater than a and it's equal to 0 when t is less than a, then Laplace of g of t equal to e to the power minus as f of s. So here only we will multiply e to the power minus s. I will solve some examples based on second shifting property, then you will clear this one. In this example, find Laplace of g of t if g of t equal to cos t minus pi by 3 when t is greater than pi by 3 and 0 when t is less than pi by 3. So in step 1, we will calculate first f of t is here cos t. Then a is here pi by 3 according to second shifting theorem. Then step 2, we will calculate Laplace of f of t. Laplace of cos t is s by s square plus omega. Omega is 1 here, so s square plus 1 square or 1 we can write. So our f of s is s divided by s square plus 1. Then in step 4, from second shifting theorem, we know L of g of t is e to the power minus as f of s. So here g of t e to the power a is pi by 3, e to the power minus pi by 3 into s into f of s is, we got s by s square plus 1, s by s square plus 1. So this is your final answer, second shifting theorem. Then change of scale property. Usually we will get like this f of t, and if they will ask Laplace of f of t, they will give, and in other term they will ask Laplace of f of 3t they will ask, or Laplace of f of t by 3 they will ask, or Laplace of f of t by 4 they will ask. That time we will use change of scale property. Change of scale property is if Laplace of f of t capital of f of s, then Laplace of f of a into t, you just divide a f of s by a, and in case of division, Laplace of f of t by a, you just multiply it, a into f of s a. This is the formula for change of scale property. So some examples we will do. So in this example, Laplace of f of t is given 9s square minus 12s plus 15 divided by s minus 1 whole cube. Then find Laplace of f of 3t. We have to use change of scale property. So Laplace of f of 3t, 3 is multiplying, so you divide 1 by 3 f of s by 3. So finally we will get 1 by 3 into f of s is 9s square. This term is f of s. So here in all s term we will divide 3. 9 into s by 3 whole square minus 12 into s by 3 plus 15 divided by s by 3 minus 1 whole cube. If you solve this one, you will get your answer. Then this is I, then double I, find Laplace of f of t by 3, then you multiply 3 into f of 3 into s. So 3 into 9 3s square minus 12 into 3s plus 15 divided by 3s minus 1 whole cube. This is your answer. Then multiplication with t to the power n. If Laplace of our function f of t is capital Fs, then multiplication with t to the power n Laplace, t to the power n f of t, you will get -1 whole to the power n, then d to the power n divided by ds to the power n f of s. We have to do the derivative n times. So if we solve one example is Laplace of t cos 3t. Step by step we will do. First this is our f of t, then this is t, n is here 1, t to the power 1. So in step 1 we will do Laplace of cos 3t. It's s divided by a square plus omega is 3. This is your omega, so 3 square is 9. S divided by a square plus 9. Then in second step, we will multiply t. This is our f of s. So this is our f of s. Then we will multiply t, Laplace of t into cos 3t. We will get -1 to the power n, -1 to the power 1. So it's minus into d by ds. Single time we have to do the derivative. F of s is s by a square plus 9. S divided by a square plus 9. It's in u by v form. Do the derivative u by v form. Then you will get your answer. Next, if here f of t is divided by t, function is divided by t, then Laplace of, if given is Laplace f of t is f of s, then Laplace of f of t divided by t, you have to do the integration s to infinity f of s ds. In case of multiplication, you have to do the derivative, and in case of division, you have to do the integration. So for example, Laplace of sin t divided by t, if you will do, step by step we will do. So step 1, our f of t is this term. Laplace of f of t, first we will do Laplace of sin t, omega is 1 here, so sin is omega 1 by a square plus 1. Then in second step, Laplace of sin t divided by t, we have to do s to infinity, f of s is 1 by a square plus 1 ds. So 1 by 1 plus a square, it's tan inverse s by 1, a is 1, limit is s to infinity. If you put the limit, tan inverse infinity, it's pi by 2 minus tan inverse s. This is your answer. This is division by t. This is end of part 2. Division by t and multiplication by t is always important. Thank you friends. Thank you for watching my video. Thank you.